Hey everybody. So we are looking at 3.4 today, solve equations with variables on both sides. But before we get into this real quick, I'm going to have you guys try a warm up dealing with our last lesson when we were solving multi-step equations. Okay, so go ahead and try out this warm up on your own and see how much you remember. Okay, so if you guys, remember, there's quite a bit going on here. The first thing we're trying to do is just simplify this as much as possible, and then we can start solving for m. Okay, the first thing to look out for if you ever see distribution, it's probably the first thing you're going to do. Okay, and that's what we're doing here. So let's go ahead and distribute our 4 into the parentheses. Okay, I'm going to go ahead and just bring down everything else. So we got a 15, 4 times m is a positive 4m. 4 times negative 2 is negative 8 equals 21. Okay, from here, I'm just kind of taking a look and see if there's any other simplifying I can do. And it looks like, yeah, we have some, subtraction we can do here. So that's probably where I'd want to start. We have a 15 minus 8, which would give me a 7, which, by the way, I'm going to start by bringing the 4m down and then do the 15 minus 8, which gives me a positive 7 equals 21. Okay, and then from here, now we can finally start doing our solving. Okay, so remember, dealing with addition or subtraction first when solving for m. So we'll get rid of the 7 by subtracting. Okay, so those are gone. We have a 4m equals, it looks like 14. Okay, last thing here, we can get rid of this 4. It's being multiplied by m, so we're going to divide both sides by 4. Okay, here's something that we don't see happen very often, but is definitely something that could happen. 4 does not divide into 14 evenly. All right, so we're going to be left with a fraction here, but I want to reduce this fraction as much as possible. Okay, and I know a 14 over 4, I know 2 at the very least can divide into both of these. Okay, 2 goes into 14 7 times and 4 2 times. So I'm going to reduce that down to a 7 over 4, or sorry, 7 over 2. And there we have it. Okay, so yeah, that's just sort of a little reminder on solving. Today we're going to be doing a bit more. We're kind of taking it another step here. And yeah, again, we're solving our equations with variables on both sides of the equal sign. So go ahead and get this title at the top, copy the slide here, and then we'll try this one out together. Okay, so on this problem here, yes, as you notice from the title and just by looking at it, we have variables on both sides of the equal sign. All right, usually when that happens, that is one of the first things we'll want to deal with. All right, I want to get these to the same side. And let's just read what it says off the side. It says, collect the variables to one side of the equation and the constants to the other side. All right, so yeah, first let's deal with these variables. Here's the first thing to know, or I guess remember, because I'm sure you've done this before. I have the option to bring my variables all to the left side of the equal sign, or I can bring them all to the right side. It doesn't really matter which I choose. I'll get the same answer either way. I just always recommend choose what looks easiest to you. Okay, what I like to normally do is I like to get positive numbers. I just like to work with them better than negatives. So here's what I know. If I take this minus 8x, if I add an 8x to both sides to bring it over to the right, I'm going to end up with a positive 12x. I like that. So I'm going to start by adding and bringing my 8x over to the right-hand side. Okay, just so you know, I could have brought the 4x to the left. I could have subtracted 4x from both sides. Okay, and that would have been fine. I would get the same answer, but I'm just choosing it to do it this way. Okay, so let's see what happens. Our 8x's are gone. This positive 7 comes down on the left. On the right, got that 12x minus 17. Okay, now two-step equation, right? We know we need to deal with this minus 17 first by adding 17 to both sides. And it looks like we're getting, what, 24 on the left, 12x on the right, 17s are gone, and then we can divide by 12. Okay, so again, just kind of like another little baby step here, but having variables on both sides is, quite a bit different than what we've been doing the last few lessons. All right, and if you ever get 2 equals x, flip-flop those around, right, as x equals 2. Okay, so let's try another one together where we still have some variables on both sides. So yeah, take a second, copy this. All right, so I noticed, we have these p's on both sides of the equal sign. So now let's get them to the same side. I can bring the 13p to the right. I can bring the 17p to the left. It's completely up to me. I'm going to choose to bring the 17p over to the left. Okay, it's being, it's a negative 17p, so I have to add 17p. Okay, just by the way, the reason why I did this is I kind of looked ahead and I knew that, oh, 17p minus 13p, that's going to give me a positive number. That's kind of nice. Okay, so I have 19, okay, negative 13p plus 17p, or remember, you can look at it in reverse. 17 minus 13 looks like we're getting a positive 4p. On the right, those are gone, have that negative 5. Careful with like missing all these negatives and stuff like that. Okay, now I can solve for p here. I have a positive 19. I have a positive 4 being multiplied. I got to get rid of that positive 19 first, right? So I'm going to subtract it. So I got 4p on the left, on the right. Two negatives combine to get a bigger negative. So it looks like I'm getting a negative 24. Now I can solve for p here. It's being multiplied, so I'm going to divide. Okay, so it looks like p is going to equal a negative 6. Okay. All right, so I think the next slide, yeah, I'm gonna have you guys go ahead and try out one of these on your own. So go ahead, copy this, try it out, and we'll look it over. Okay, so variables on both sides, negative 3k over here, negative 2k over there. So let's get them to the same side. If I were doing this problem, I would probably add a 3k over to the right, to both sides. Okay, but if you added a 2k to both sides, that is also fine. You're just bringing your case to the left. I'm going to bring mine to the right, right? So 3k, add 3k. Again, I like this because it's going to give me a positive 1k. So I got a 9 on the left. Those are gone. 17. And then, yeah, 3k minus 2k gives me a positive 1k. Or we just read it as k, right? We don't need to put the 1 there necessarily. Okay, basically last step, because this is a one-step thing. I just need to subtract 17 from both sides. And it looks like, what are we going to get? Negative 8 here. So we got a negative 8 equals k, and flip it around, k equals negative 8. Okay, so let's ramp it up a little bit. All right, example number 3 here. Let's do a problem that just has one extra step, basically, a little bit more elaborate. All right, here's what I notice: variables on both sides, but I also have distribution that I can do. And if you guys remember, that's normally the first thing you will always do, and that's exactly what we're going to do here. So I'm going to start by distributing my 5. Okay, so I'm just going to bring these down. 3 minus 4a over on the right. 5 times a is a 5a. 5 times negative 3, negative 15. Okay, now let's go ahead and bring them to the same side. I'm going to choose to bring my 4a over to the right-hand side. It's being subtracted, so I'm going to add it. All right, so they're gone here. I have a 3. Over on the right, excuse me, it looks like I have a 9a minus 15. Okay, and now I can solve this two-step equation, right? So I'm going to add 15 to both sides. Okay, looks like I have 18 equals a 9a. These are all working out kind of nice, right? So go to divide by 9, and it looks like I'm going to get 2 equals a, right? I'm going to go ahead and just flip it around and write it as a equals 2. Okay, so let's see here. I'm going to go ahead and have you guys try one of these on your own. Copy it, try it out. Yep, so yeah, just like the last one, it looks like variables on both sides. First thing though, distribution. We have this 2. We can distribute it into the parentheses. Let's start there. Okay, on the left, 5x minus 7, bring it down. 2 times x is a 2x. 2 times 1, positive 2. Okay, on this one, I'm going to choose to bring my x's to the left because I like that that will give me a positive number. All right, so I'm going to subtract my 2x over here. And again, I just want to point out, if you chose to subtract your 5x over to the right, that is fine. We will get the same answer as long as we both do our work correctly, right? So yeah, looks like we're getting a 3x minus 7 equals 2. Okay, last thing, we're getting pretty good at these multi-step equation solving. So if I were doing this, I'd probably do this last couple steps in my head. Add 7 to both sides. I got a 3x equals 9. Divide both sides by 3. I got an x equals 3. Okay, I don't mind if you guys do that. The solving stuff, I'm sure it's something you're all very familiar with. So feel free to skip steps here and there. But though I would like to see this one, especially on this lesson, since it's such, the point of it. All right, let's see where we're going here. Okay, so these last couple questions are going to have this direction. Solve the equation if possible. Okay, so sort of alluding to maybe it isn't. All right, so let's just kind of see what happens on this. Take a second and copy it. Okay, so this looks a lot like the other problems. For all we know, this is going to be solvable, and it's going to be just like any other. So I noticed variables on both sides. Good thing to just kind of keep in mind. But we have distribution, so let's start there. So distribute 3. I've got a 3x equals 3 times x is 3x. 3 times 4 is positive 12. Okay, and now I'm going to get my variables to both sides. You can see what's about to happen, right? I'm going to bring my x's over to the left and subtract 3x over to the left here. Okay, 3x minus 3x. Normally I would just cross this out, but we need something. There's nothing else over on the left-hand side of the equation, so we need to write something, right? And that would be a 0. Okay, so instead of crossing them out, I'm just going to write, okay, we got a 0 over here. These I will cross out, and we got a 12. Okay, and here's the thing. We eliminated our variable. I mean, really, if you want to cross them out on both sides, it makes it more obvious. Yes, the variables are gone, and we're left with this thing. Okay, so here is the question. After we eliminate our variable, we want to see if what is left over actually makes sense. Okay, does this make sense? Does 0 equal 12? No. No, it doesn't make sense, right? So when that happens, your answer, when you eliminate your variable, is going to be no solution. Okay, and what that means is that there is not a value for x. There's not a number we can plug in for x that would make this equation work. There is no solution. Okay, that's what happens when you get this ending here that does not make sense. 0 does not equal 12. Okay, let's look at one more. Okay, so you might be able to just in your head already kind of piece together and see what's going to happen here. But let's go ahead and do it. So take a second, copy this. Okay, so let's start by distributing our 2. Looks like I'm going to bring down this 2x plus 10 on the left. On the right, looks like I have a 2x plus 10. Okay, so kind of interesting. Same thing on both sides, but let's go the distance. Let's actually solve this thing. So just like before, variables on both sides. I'm going to go ahead and take this 2x, subtract it from the left. Okay, and if you guys notice here, again, variables are eliminating. And what we're left with is a 10 on the left equals 10 on the right. So again, variables are eliminated. We're asking ourselves, is what we're left over, does it actually make sense? Does 10 equal 10? Yes. Sometimes I like to put a little check mark. Yes, it does make sense. Okay, so our answer is not going to be no solutions. It's actually going to be the opposite of that, and it's going to be all real numbers. Okay, and again, it's literally the opposite of that last answer. All real numbers means every single number, I guess technically every real number, which is really all we deal with in our class. All numbers that we plug in for x would work for this equation, any number. Okay. So just be careful with getting these two things mixed up. They ended very much the same, but seeing if this equation actually made sense was the difference between an all real numbers and when it didn't make sense, a no solution. Okay, cool. So yeah, that's kind of us getting pretty close to the end of our equations lessons. You know, we're gonna eventually get into doing this stuff with some good old inequalities. But if you're feeling good here, the inequalities is going to be just as easy. So yeah, guys, I'll see you in class. Have a good one.